Hello and welcome to this video. In this video, I'm going to go over the objective Understand TCP IP for the MTA 98366 Networking Fundamentals certification. So some definitions that we want to go over for understanding the TCP IP. The first one is ping. And so ping is actually a utility that we have built into the operating system. And what it does is it verifies that we have a connection. So you can see here the definition says TCP IP is configured correctly. Really what this does is, so we use this during troubleshooting. If we're having problems making a connection to another computer, we can use ping. And what ping does is it sends out 4 32-bit packets of information to the host destination, or the destination host, and then the destination host is going to bounce that back, and it's going to let us know that that other computer or server or whatever is or is not reachable. And again, we get this term ping from sonar. So in submarines, they would send out a sound wave, and if the sound wave hit something out in the ocean, it would bounce back and let them know that there was a contact out there. And so in the same way, we use ping to send out a packet to let us know if we can reach another network interface card on a server or another computer or something like that. So that's what ping is for. Tracert or TraceRT, this is actually a Microsoft diagnostic utility that goes a little bit further than ping. What this is going to do is this is actually going to it's going to send out the packets, but then it's going to ask for kind of like a return from each of the routers that packet goes through. So this we would use more for diagnostic purposes outside of our subnet. Because obviously, if we're trying to connect to something inside of our own subnet, we're only going to have one router, and it's not going to pass through the router to get to that. But this is very helpful for verifying if we have a route to a remote host, so like a server. And then Pathping, this is something that goes kind of like combines and goes beyond ping and TraceRT together. And what this does is this actually shows us information about latency, and if we're if we're dropping packets, if there's it gives us a little bit more information about problems. So if we ran a tracer and we saw that the request timedown didn't go, we could run a path ping, and that might give us a little bit more information about why it's not going through. Or maybe we run a tracer and it goes through, but we're still having connection problems. That path ping might be the next choice that we want to have to establish what is actually going on there. Then we got IPconfig. So IPconfig is a utility that we use to display the TCP/IP information for the computer, and so that's going to be your IP address. That's going to be the default gateway, the default subnet mask, if the DNS router that it's using. So that kind of information is going to be configured, which again is very important. This is where we would find out if that computer had rolled over into a PIPA, because we're going to run IPconfig, and it's going to show us that we have a IPv4 address starting with 169.254. And then we have Netstat. Netstat is a utility. It shows what ports are open and listening on our current TCP/IP connection. So this is very helpful for setting up our firewall protocols. If we say we are running an online game, and we want to make sure that we can connect through to that online game, what we do is initiate the game and then run a netstat and see what ports are open and listening, and that would indicate the ports that we would need to open up on our firewall. All right, so this is actually this is a screenshot of actually running the ping utility, and you see I pinged. If you look at this line here, it says C:\users\swipe.jacob, and then ping 8.8.8.8, and that's actually the router for, or the IP address for the main Google server. And so I pinged Google, and as you can see, what it did is it sends out 32 bytes of data, and it sends it out 4 times, and we see that we got a reply, and you see four lines here. It says reply from 8.8.8.8 bytes 32 times 7 milliseconds, TTL 115. And so that's similar because that's a very standard. I mean, the Google the Google server is a pretty standard server. Like we're not going to see a lot of different routes to get to it. And then we have ping statistics. We see that we sent 4 packets. We received 4 packets. None of them were lost, and it took 7 milliseconds for the round trip. That's you think about that. That's really fast. But now, if we take a look at, I want to show you a couple other pings. So here, I actually pinged the loopback address, and if you remember from our IPv4 and IPv6 review, the loopback address is the IP address that we use to actually have our NIC, our network interface card, test itself. And so let's say that we ping all of our local hosts, we ping a remote host that we know of, and we're not getting anything back. Well, the question is our network interface card bad? And so we would actually ping our loopback address, which in IPv4 is 127.0.0.1. And you can see here that we did this. The time back is 1 millisecond. And actually, when we go down to the statistics here at the bottom, we see the minimum was 0 milliseconds with the average of 0 milliseconds. And that's because it didn't have to go anywhere. That ping, it sent the packets out and basically to itself. It was kind of like handing it from your right hand to your left hand. It was right there. And so that's why that happens really fast. And then in the next slide, I'll show you the IPv6 loopback. So here we see I've pinged the ::1, and so remember that's our loopback address for IPv6. And again, we see that we got a reply in less than 1 millisecond. If we look down the statistics, again the minimum is 0 milliseconds because again, what we're doing here is again when we ping our loopback address, that's actually just sending the packets from the NIC back to itself to test if our network interface card is working. Next, we've got Tracert or Tracert. And what this is going to do is, so again, I've initiated a Tracert for the Google server. And so what we see here is that when we're tracing the route, what this is actually going to do is it's going to record each of the routers that this packet travels through from our host to our remote destination. And so we see here it gives us the time that it sends, less than 1 millisecond. Then the next line 2 is 3, 5, and 4 milliseconds. So we see each of these lines here, these IP addresses at the end, these are actually the IP addresses of the routers that this request is passing through. And so we see as we go through each of these, we actually saw 4 requests timed out. And so something happened there. I would say because we're doing this from inside the school network, this is probably indicative of some sort of a firewall check or something like that. Where it then did allow it through. And then we see down at the very end, line 12, dns.google. So we actually made it to the Google DNS server and trace complete. And so this would be a successful trace. And it shows us, again, each of these lines represents a router that our message is traveling through from our computer. What you see here, this is my IP address, 10.104.4.1, out to the Google DNS router, our server, which is 8.8.8.8. This is actually what an unsuccessful tracer looks like. So here I went ahead and I ran a tracert for 10.10.10.10, which I know, so that's a private IP address that is not in my subnet, because I know that my, if we go back to the previous slide, we see that my IP address is, I believe, like 10.104. And so we're not in the same subnet, so I should not be able to reach this host at all if it exists. And so I went ahead and ran a tracert on that one, knowing that it's not going to get there. So as we see, it goes out from my computer, and then it goes out to probably what is kind of like our default router, and then it stops. Request timed out, request timed out, request timed out, and we see all the way down and up to 30 maximum hops, and we see that no matter where it's trying, it can't get there. And the reason is because this is if this IP address exists, it exists inside of a private network that I don't have access to. And so you see we're going to see request timed out, and it's not going to make it there. And so this is a complete trace, but an unsuccessful trace. Then we also have Pathping, and so here again, I've run a Pathping on the Google DNS server, and what this is going to show is it's not only going to show, and actually, if we were to go back and look at the tracer that I did for the Google server, we'd see that it only went through the first 4 steps, and of course, like the fourth step was the one where we had the request timeout. But what it's not going to actually go through all of the hops. It's just going to take the first couple hops, and then what it's going to do is it's going to take that information and it's going to compute some statistics. And so we're going to take a look here. We see, hop 1, it lost none of the packets. It sent, it lost none of the packets that it sent, and so it was 100. And we see that these statistics. So this gives us a lot more information. Now, obviously, at this level, most of this is not going to make sense for us because we're just. But this is a very important tool. Like I said, if we're having intermittent or latency issues in a connection to a remote host, this might be a tool that we want to use after establishing that we can ping that server, that we are getting through with the tracer. Maybe we want to use a path ping to see if we're having some latency issues somewhere on the line. And then this is the IPconfig. So I ran IPconfig on my teacher computer here, and you see what it does is it comes up with our Ethernet, and so it gives me the DNS suffix. So this is the domain that my computer is a part of, and then it gives us our link local IPv6 address. Now, if you remember link local, what that means is this IP address gives me this is the private IP address that I'm using inside here. Then we see I have an IPv4 address. So this tells us that that this network is running a dual stack IP addressing. And then we see my subnet mask is 255.255.254.0. So this tells us that we're in a classless subnet masking because we don't see just zeros or 255s. And then the default gateway. So this is the gateway that we use to get out. So 10.104.4.1. Then we also see some information about tunneling. So if we were going to be using tunneling, these are the addresses that we use for tunneling. But again, this is the IPconfig. If this computer couldn't reach the DHCP server, we would see here in the IPv4 address, we would see 169.254, and that would tell us that we've rolled over into APIPA. And so there's a lot of good information that we can find here. This is also helpful if you want to ping a computer in your network. You can go to that computer and run the IPconfig on that computer to find out the address so that you can ping that from the computer you're trying to troubleshoot. And then this is Netstat. So I ran Netstat on my computer, and the list is actually much longer than this, but I just kind of truncated it here just for the sake of brevity and not putting a bunch of more slides up here. But as you can see, basically what it's doing is it's looking at each of my connections, and it's saying it's giving the local address, and then we see here so we have the IP address, and then we have the port on the back end, and then it shows where it's connected and the status of that connection. Again, this is very helpful if you're setting up some sort of a remote connection or like an online game or some sort of a chat or something like that. If you have a very stringent firewall setting, you may want to open up that program and run your Netstat to see what ports need to be open to make that work on your firewall. So that is the Understand TCP IP crash course. Hopefully that helped you out a little bit. Have a good day.